Welcome back again. So we have seen that the electron motion in an electric field or that interaction of electron in electric field, and through that we say that the equation of a force when electron is interacted in a electric field. So that maybe we can write F is equal to what? Minus E into E here. Because we say that interaction of electron electric field. Here we say that vector here, both are vector. Similarly, we have seen that the interaction of electron in a magnetic field, that we can write minus E vector V cross B. Now this B is nothing but what? A magnetic flux density, and that V is nothing but the velocity of electron in the field. So this equation belongs to that interaction of electron in magnetic field. Now then we talk about that interaction of electron in an electromagnetic field. So we need to combine these two equations. We can say that interaction of electron in electric field as well as interaction of electron in a magnetic field. So that is nothing but what? Interaction of electron in a electromagnetic field. But we should know that what is the motion of an electron and what will be the direction of the electric field and a magnetic field. If we consider that the electric field and a magnetic field both are in the same direction, in that case that electrons are, even if it is propagating through that field, so magnetic field will not exert any force on the electron, because electron motion is totally depending upon the electric field. And that type of a tube or that type of a application we can use in a linear tubes. There in a linear tube we use a magnetic field that will coincide with the axis of the electron beam, and that magnetic field used to hold those electrons in a axis so that it will travel the length of the tube. So because we say that electric field and magnetic field both are in the same direction or a opposite direction. Okay, but magnetic will not exert any force on this electron motion. So if you write the equations here, we can say that E is equal to what? Force is equal to E cross plus your V cross B. Now this one is about the equation, because interaction of a electron in a electromagnetic field. So F is equal to minus E, that is about the charge, electric field intensity, your velocity, and a magnetic flux density. Now we say that here electric field E and a magnetic field both are linear. Okay, with their act, they are propagating that the electric field and magnetic field, both the fields are in the same direction or in the opposite direction. Okay, so that's why that is to be used in a linear tubes. But if you consider that if electric field vector or magnetic field vector, they are perpendicular. Okay, that is about, we can say that we have the electric field likewise here vector, and a magnetic field vector that is perpendicular. So in that particular case, that magnetic field force the electron to move, or that their position or their orbital position there means, here the magnetic field exert a force on the electron so that they will bend, or they will change the direction. That electron will change the direction. Okay. So if in this particular case here, that electric field and magnetic fields both are right angles to the each other. So that is called as a perpendicular. Your electric field vector and magnetic field vector is perpendicular. And this type of field is called as a cross field tubes. This field is called as a cross field, and these fields are used in a cross field tubes. In that a cross field tubes, electrons are emitted from the cathode, and that electrons are accelerated by the electric field, but the whatever the electrons are getting their energy, or they will get the gain some velocity because of that acceleration of electron because of the electric field. So they will get the more velocity because of the electric field. But there is a magnetic field in their path, so that's why that magnetic field will bend those electrons in that particular path. So if that electrons are interacted in the magnetic field, then they will that electrons will be bent by the magnetic field, and that is the principle is used in a cross field tube. And now these equations, we say that F is equal to, we say here, force, that is about the force exerted on the electrons, that is F here. And this particular equation, we can say that it is that equation is called as a Lorentz force equation, because that Lorentz force equation is saying about that force acting on the electron because of that presence of a electric field and a magnetic field. So this is called as a Lorentz force equation. This is called as a Lorentz force equation. F is equal to this one, E in bracket of E bar plus V bar cross B bar here. That is called as a Lorentz force equation. Now we can write this equation in a Cartesian coordinates or a cylindrical coordinates, or we can write in a spherical coordinates here, and we'll get that equation of a force in terms of all these coordinate system. But if you see that in most of the cases we are using spherical coordinate or a cylindrical coordinate to fulfill the equations here. That is for the antenna. Now that is about your interaction of the electrons in the electric field and the magnetic field. With this, we will end that topic of the interaction here. If you have any questions or a query, you can ask. Thank you.